There's week 7. There's a lot of parts to this one. You definitely need to understand a lot of different graphs. I think the most difficult one is the normal curve or bell-shaped curve, and being able to do it on Excel. There's a homework assignment. There's a knowledge check. This is just to make sure you understand the normal curve. It's just a basic problem. And then there's the discussion board. The outline, a lot of the data we'll probably use today, but it's also used here. That's everything. I don't remember if it's this class or my other class, but a lot of people are not doing the discussion board. The discussion board is weighted in the 40% area, so that can bring your grade down very quickly. So if you haven't done them, make sure you're doing them. So the first part for the class is some definitions. The first one is data. That is the information being asked or measured. It could be the grade on the exam, height, age, how many rooms you have in a house, how many cars are listed to a house, any type of information that's being asked. What's your favorite color? What's your favorite ice cream? The data is what you're measuring. Frequency is the number of each type of data. So how many A's were there? How many B's were there? Or if you're asking how many pets somebody has, then it would be each of those answers. So the frequency is how many of each. So if this was grades on the test A, B, this would be the number of A's. Mean we've discussed in the last chapter. You add the data up, divide by the number of data. Now this is a regular average, it's not the percent. So you're just adding up your data and dividing by how many there are. The range is the largest number minus the smallest number. the median is the middle number. What you have to be careful of is the data has to be in order first. And then there's two cases. One case is if it's an odd number. Of data, it's the middle number. If there's an even number of pieces of data, add the two middle and divide by 2. These definitions are in that outline I showed you on Blackboard. So you don't have to write them all. It's up to you. Median mode. So median, this almost looks like middle. Put a dot above it, MID. Mode, MO, most often. So it's the data with the largest frequency. There's 3 cases. There could be no mode. That happens when repeat, or the frequency is 1 for all of them. Another case is there's 1 mode. The one with the largest frequency or more than 1 mode. And we'll go over examples of all of these. So if we have these 4 numbers and we want to find the mean, median, mode, and range. For the mean, we add all of them up and divide by how many there are. So we would take 70 plus 88 plus 90 plus 100. So if we add up the data, we should get 348. Divided by 4, which gives us 87. Median is the middle value. This one has an even number of them. You're finding the median and it's an even number. Add the two middle and divide by 2. You're finding the middle of these two values. You get 89. Questions so far? Trying to make it clearer. Word. So for the median, it's the middle value. So since it's even, we want in between these two, which would be 89. Mode. Mode is the one that repeats the most. Since none of these repeat, the mode is none. You don't want to put 0 because 0 could be a value. So you have to put no mode or none. And then the range is largest minus smallest. Any questions on that? Okay. Let's see how adding one more 70 changes it. Find the mean, median, mode, and range. For the mean, when you add it up, you get 418, and now there's 5 of them, so it's 83.6. Median is the middle value. There's an odd number of them, so the one in the middle is the 88. Mode, most often, there is one that repeats, the 70 repeats, so it would be 70. And the range is the largest minus the smallest, which is again 30. Any questions on that one? How about this one? Find the mean, median, mode, and range. Is there any questions on this last one? It adds up to 756. We divided by 9. Okay. Any questions on that? Median is the middle number since there's 9. I count inward. 1, 2, 3, 4. That one's the middle. Mode is the most often. There's 3 70s. There's 2 88s. There's 3 90s. And then there's only 1 of the 100s. So our frequency is 3 of the 70s, 2 of the 88s, 3 of the 90s, and 1 of the 100s. Mode is the one that's most often. So that would be the frequency of 3. So since there's 2 of them, it will be 70 and 90. A lot of times students want to include this one because it has a frequency more than 1. But you go with your largest frequency, and then if there's more than 1 with that same frequency, you use them. So if there was another 88, we would have had 70, 88, and 90. Any questions on that? And then change the lowest and highest number so the range ends up still being the same. Any questions on that?
Yeah, or not. Just set it right there.
Hot as heck in here.
Thank you.
Someone has their microphone on. A qualitative data is a quality. Usually non-numerical. There's a couple special cases. For the most part, it's a quality, it's not a number. Some examples: favorite color, if we were talking about grades, it would be the letter grade. A, B, C, D. The special cases, when you're thinking of qualitative and you're looking at a numerical value, if you would put it in an order, putting it in order wouldn't make any sense. Like if these are grades, putting them in order, this is the lowest grade, this is the highest grade, so it has a meaning. Whereas if you think of your phone number, putting them in order really doesn't mean anything. Maybe the area codes will all be the same, but finding the average of a phone number doesn't have any meaning. So numerical wise, a phone number is qualitative, even though it's a number. The same thing with your zip code. Finding the average of zip codes doesn't make any sense. And so zip code would be another case. But for the most part, they are non-numerical. Anything you're looking for, what type of pet a person owns, would be qualitative. When you're using qualitative data, we were just finding mean, median, mode, range. Well, when you have qualitative data, it's not a number, so you cannot find the mean. Doesn't make sense to put them in an order, so you can't find the median. And again, range is subtracting. So the only thing from this data set that you can find is the mode. Whichever letter grade was the most, whatever pet was showed up the most. So for qualitative data, you cannot find mean, median, and range. Numerical data is called quantitative. The quantity or numerical value. Age, price of an item, number of pets in a house, but it's a number. Because it's a number, you can find mean, median, and range. You can find all four. Any questions so far? Now, when we have quantitative data, there's two different types of quantitative data. There's discrete and continuous. These are both quantitative because they're a number. Discrete data are integers. You can count them. Continuous are any real number. That's like all those decimals, 1.5, 1.4, 2.68, 1/3. So it can be any value, and the data is continuous. In Walmart, we look at the number of registers. We can count that. There's 2 registers open, there's 5 registers open. The number of registers can be counted. That means it's discrete. There's not going to be 1.5 registers. So this is a counting value. You can count them. That makes this discrete. The time you're waiting in line, that could be fractions. You could wait for 2.5 minutes. You could wait for a half hour, 3/4 of an hour. So it can be fractions and decimals. When you can get fractions and decimals, it's continuous. The most common one is time. Weight could also be time, weight. I think those are the 2 most common. Any questions in the difference between qualitative and quantitative, and discrete and continuous? Positive. We look at this data, and we want to make, we're going to make 2 different graphs. The first, you want to make the frequency table. For frequency means how many. These are a favorite color, a sample of 25, and this is on Blackboard under the first, I forget what I call it, chapter 5 out. I think it says outline, but this is on there. It's favorite color. Sample of 25 fifth graders were asked their favorite color. R is red, G is blue, G is green, and Y is yellow. Now there's a project you're going to be doing. I'll probably put that up today. It won't be due for at least 4 weeks. But there's a homework assignment that goes with it also. But that won't be due this week. And you're going to have to find your own data. One qualitative and one quantitative. Now notice this one, it's colors. So it's not a number, which means the type of data is qualitative. And so when we ask them, we got red, blue, green, and yellow. And I'm going to add them up. Frequency is how many there are. So if we count the number of red, that would be its frequency. Here. blue, there's 1, 2, 3. Green, 1, 2, 3, 4, 5, 6, 7. Yellow, 1, 2, 3, 4, 5. Add them up and make sure we added correctly, and they add up to 25, and it said there was 25 of them. Any questions on that part? Find the percent, where we take how many there are, divide by the total, and multiply by 100. So how many there are divided by the total times 100. Go ahead and find the other three. Then when you add these up, they should add up to 100%. Now, if you have ones where you need to round, if you look, maybe you're rounding to the 10th or to the whole percent, this could be off a little bit. But if you didn't round, it will always add to 100. But it should always be close, 99.9, 100.1, but it will be close to 100. Any questions on that part? I'm going to draw the bar graph. I'm going to run out of room. A bar graph is just that, bars. You list each of your data on the bottom, and then the frequency goes up. So the frequency, our frequency was number of students. Look at the frequency. It went up to 10. So I counted by 5. Probably could have went a little smaller numbers, but that's okay. Across the bottom is your colors. And label our graph. Favorite color. So the first color was red. And 10 people said red. A bar graph does not touch. A histogram does. Color was blue. Blue went up to 3. Green. Green was 7. And the last one, yellow was 5. You should always label your axes. The bars will not touch, and then you should have a title. So a bar graph uses the frequency. We're going to do a pie chart that uses the percent. Is there any questions on the bar graph? We're also going to learn how to use these on Excel. Pie chart. A pie chart puts the percent in a circle, like a pie. Now, I'm not too worried if they're not exact, but we have a 40, a 12, a 28, and a 20. Well, we know half would be 50%, and the 1 is 40%. If we went a little bit less than half, %, which is any questions so far? Another one. 12%, 28%, and 20. Well, here would be 10, 40, and 50 is half. So if we went a little bit bigger, that would be 12. And 12% was blue. This would be a quarter. If we went a little bit more than that, that would be our 28. And the other one would be our 20. Yellow. So I'm not worried about it being exactly right, just close. I mean, the largest one, the 40%, shouldn't be the size of the 20%. Make sure the largest one is the largest and that it makes sense. But it does not have to be exact when you draw it. Any questions on it? For this data, we want to be able to graph a histogram, a stem and leaf plot, and a box plot. For the histogram, when you're making a histogram resembles the bar graph, only the data is all together because it's thought of as continuous. So they will all touch each other. Then we need to decide what we need to count by. The histogram will look like this. But we need to know what units we're counting by. We know we're starting with 17 because our data starts with 17. But to find your units, say we want about 7 bars. find the range. 45 minus 17. So if you wanted, you could find the range first, which is what I did, and then find a number that divides into it. If you're doing one in a class and they tell you it has to have that many bars, and you have a decimal, round up. So when you go to divide by the number of bars you want, if it's not a whole number, round up. If you can choose, pick one that will work out. And that's why I chose 7. I want to count by 4 units. You take your range and divide by the number of bars that you want. We're starting with 17, 21, 25, and what I'm doing is I'm counting by 4. 25 and 4 would be 29, 33, 37, and I need to go until I'm past the 45. Age. This was 25 college students, and this is number students. And I forgot to ask, what type of data is this? These are numbers, and finding the average age would make sense. So it's quantitative. Now, I just took the whole number, but it is continuous because you could be 17 and a half years old. So this would be continuous data. It's time. Any questions so far? Oh, notice that I went to 49. The reason I went to 49 is because I have a 45. When you're finding your bars, this one goes 17 up to 21, but not including it. 21 goes into the next one. And that's why 45s would go into the next one. So we want to count how many there are from 17 to 21, but not including 21. They're going up to here. 21 goes into the next bar. We count these ones. 10, 11, 12, 13, 14. The next one's 21 up to, but not including 25. So that would go to here. That 25 that's there goes into the next bar. 1, 2, 3, 4, 5, 6, 7, 8. When you have a histogram, the bars cut. 25 up to but not including 29. There's only one. 29 up to 33 but not including it, there'd be one. And there isn't any more until 45. And 45 goes into the bar after it. So it would be here and not here. Any questions on that? I think we have enough time for the stem and leaf. Any questions on that one? And these are all recorded also online, the whole outline. Stem and leaf. The leaf is the rightmost piece of data. So notice in this data, this would be the ones position. And anything in front of that is your stem. And in this case, there's only the tens position because we don't go up to 100. The stem goes from 1, we have 10s, 20s, 30s, it goes up to 4. Now, if someone was 9 years old, then you'd have a 0 in the stem and a 9 in the leaf. And in this case, we have 10s. There's 2 that are a 17. So you put 2 7s. So that would be 17 and 17. You want to keep the columns lined up. Then 8, there's 1, 2, 3, 4, 5, 6, 7 of them. And 9s, 1, 2, 3, 4. So that's all the 10s, 17s, 18s, and 19s. The next one is a 20. That starts here. This is the 20s. And there is one that is exactly 20. And there's 121. 2, 3 22s. And you want to try and keep these lined up. There's 2 23s. 2 24s. And a 25. If there were no 30s, you'd still have the 3 here, but this would be blank. You don't want to skip these. If there were no 30s, you'd still write the 3, but then you'd put nothing in that row. If there was a 30, it was a 32, and then there was a 40, which was a 45. So it's just another way of organizing your data. You know how many 10s, 20s, so students in their teens, students in their 20s, students in their 30s, and students in their 40s. Any questions on the stem and leaf? We will stop there. Any questions on anything?